Okay guys, so far we have discussed dielectric materials, and we discuss a lot of things like polarization, susceptibility, polarizability, etc. And then we have type of polarizations. There are three types of polarizations. One is electronics, and then ionics, and then we have dipolar or orientational polarizations. So we discuss all these things in previous lectures. So now we will move towards ferroelectric materials. Now we know that insulator are basically those materials, like insulators are those materials, they have their dielectric constant is very small. Dielectric constant is very small. So what it means? It means that if I apply electric field to insulators, okay, then what will happen? There will be no polarization inside the insulating materials. Like if I have, let's suppose this is my electric field, okay, and this is the polarization of this insulator. Like as I increase electric field, there will be no polarization in the insulators. If we apply an electric field, then there is no polarization occur in the insulator. Then such type of materials, like if I increase my electric field, there will be zero polarization in the material. This is for the case of insulators. But we know that dielectric materials does not conduct electricity. Dielectric materials they does not conduct any kind of current. Okay, so this implies that this dielectric material is a subclause of insulator, because insulator also does not conduct electricity or current. So dielectric material is a subclause of this insulator. But dielectric materials are those materials in which if once we increase the electric field, then there is a polarization inside the material. So these are such kind of materials in which the polarization is directly proportional to the electric field. Okay, because these are the materials in which the polarization is directly proportional to the electric field. So it means that if this is the electric field and this is the polarization, as I increase my electric field from 0, like before, without electric field there is no polarization, the polarization is 0. But as we increase the electric field, then the polarization also increases. Okay, this is the property of what? Dielectric material. Okay, and then we can say that this P is equal to some constant times E, where the constant is called polarizability. Okay, now there is another class of materials in which this polarization is not directly proportional to the electric field. There is another class of material in which the polarization produced due to external field, but the polarization is not linearly proportional to the electric field, or we can say that the polarization is not increasing linearly with electric field. Like the materials, the dielectric materials, okay, the dielectric materials in which the polarization is not increasing linearly with the electric field. Then such materials are called Pyroelectric material. Then such materials are called Pyroelectric material. So here I will use Pyroelectric material. Pyroelectric material. Like these are those material in which the polarization is not increasing linearly with the electric field. Like if this is the electric field, and on this way we have the polarization, and this is the electric field. As I increase my electric field, okay, the polarization is not linearly. The polarization increase like this. Then such kind of materials are called Pyroelectric material. Now here this is the graph between polarization and electric field. Okay, this is electric field. Now in this case the polarization increased linearly with the electric field, but in Pyroelectric materials the polarization is not increasing linearly with the electric field. Such kind of materials are called Pyroelectric materials. Now there is another class of materials which is called Pyroelectric materials. Pyroelectrics. What is Pyroelectric? Pyroelectric material. Now these are those materials in which the polarization depends on temperature. Like if this is the graph between temperature, change in temperature delta T versus change in polarization delta T. Like with increase or with change in temperature the polarization increases. Okay, the more I change the temperature the more is the polarization. Then such kind of materials are called Pyroelectric material. Now these materials have a great applications such as sensors. Like their application side says they can be used in the sensors, okay, power generations, etc. etc. Now there is another class of material which is called Piezoelectric material. Piezoelectric material. What kind of materials these are? Like these are the class of material. The class of material, I will define it first. Okay, the class of material in which when apply electric field then apart from polarization strain is produced. With the application of electric field, we know that polarization is produced, but apart from polarization, there is a strain is produced. By strain I means, by strain means, a strain means force. Or we can also define strain as influence that, like the influence that stretches or pull or put pressure like the influence due to which there is a stretching in the material, or there is a pulling in the material, or there is a pressure on the material, then this is called strain. Okay, so if we apply electric field to these materials, then apart from polarization there is a strain. Either there is a pull, a push, or there is a pressure exerted on the material. Then such kind of materials are called piezoelectric materials. Like these are the materials. If I plot a graph between the electric field and the strain, this is the electric field and this is the strain. The more we increase the electric field, the more is the strain. Like the more is the force on the material, or there is a stretching in the material as the electric field increase, or there is a pressure, more pressure on the material once the electric field is increasing. These materials are called what we call it, piezoelectric materials. Now next we have ferroelectric materials, which we will discuss in more detail. So next we have ferroelectric material. Now these materials, like okay, I will stop my video here, and the next video I will move from this topic. Like I will discuss these ferroelectric materials in next video. Thank you.